Welcome back, my interstellar investigators. I'm your quantum superposed celestial sales supervisor, simultaneously pitching and dismissing mysterious objects across infinite realities. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your astronomical anomalies like failed product launches. Speaking of launches, I'm happy to report that last episode's particle physics catastrophe has finally been resolved. Brad from Sales has stopped trying to disrupt the strong nuclear force through aggressive market penetration, though I should note he's now pitching a revolutionary new app called QuarkMark that he claims will do for fundamental forces what Uber did for taxis. The automated response system has calculated his chances of success as existing in a quantum superposition of zero and imaginary numbers. But today, dear listeners, we're diving into something even more mysterious than Brad's business model. The case of Oumuamua, our solar system's first documented interstellar visitor who didn't even bother to RSVP. That's right. We're exploring dark comets, the universe's most enigmatic product launch. Think of them as the cosmic equivalent of that colleague who never shows up to meetings but somehow still influences every decision. Our automated response system, still bitter about missing the Higgs boson discovery, insists it actually spotted Oumuamua first, but the email got caught in spam. It's filed a formal complaint with NASA, citing how they really should have checked their junk mail folder before making such a fuss about the first interstellar object. Though I suspect urgent, hot singles comets in your solar system might have triggered some filters. Now, gather round the quantum conference room, my probability amplitude presenters, for a tale that would make even the James Webb Space Telescope double-check its observations. I present to you the Interstellar Marketing Crisis, a story about why some things should remain unbranded, especially if they're tumbling through space at 26 kilometers per second. In the fluorescent-lit realm of Quantum Dynamics Incorporated's marketing department, specifically in Conference Room Nova, renamed after the incident where the quantum-entangled coffee maker achieved stellar consciousness, Ryan, an intern from marketing, was having what could charitably be called an astronomical advertising crisis. It had started, as these things often do, with the square-haired boss materializing in the doorway of the weekly marketing sync. "Team," the boss announced, his hair maintaining its perfect cubic geometry despite Einstein's best efforts. "I've just come from a board meeting where someone mentioned dark comets. Dark comets! It's perfect! We need a full campaign by Friday. Make them the next big thing. Think space Netflix, but mysterious." Ryan, who spent his evenings actually reading scientific papers, a dangerous habit in marketing, raised his hand. "Sir, dark comets are called dark because they're difficult to detect, not because they're mysterious or trendy." "Exactly!" The boss's hair vibrated with excitement. "They're playing hard to get. The ultimate invisible influencers. I want concepts on my desk by lunch. Make them appeal to Gen Z. Can we get one to do a TikTok dance?" Before Ryan could explain that interstellar objects generally don't have TikTok accounts, the boss had already filled 3 whiteboards with increasingly concerning ideas. Dark comets, the original ghosters. Space rocks that don't want to be found, so relatable. Oumuamua, first ever astronomical mic drop. The situation reached critical mass when the boss unveiled his masterpiece, a mood board featuring black turtlenecks, Instagram filters, and what appeared to be a stock photo of a rock wearing sunglasses. "We'll start with Oumuamua," the boss declared, his hair achieving quantum certainty. The ultimate celestial influencer showed up unannounced, confused everyone, then left without explanation. It's literally the plot of every successful Netflix series. Ryan watched in horror as his colleagues nodded along, already drafting social media calendars for objects that were literally light years beyond their reach. The quantum-entangled coffee machine, apparently sharing his concern, began dispensing espresso in patterns matching Oumuamua's actual trajectory data. "Sir," Ryan attempted, pulling up actual astronomical data, "I think we might be missing the real story." The fascinating thing about Oumuamua isn't its mystique. It's what it tells us about our own limitations. Every theory, every observation, every attempt to classify it reveals more about our assumptions than about the object itself. The boss's hair wavered uncertainly. "So, you're saying it's playing even harder to get?" "I'm saying it's a humility check from the universe," Ryan explained. "A reminder that there's still so much we don't understand. Maybe that's the angle, not mystery for mystery's sake, but genuine wonder." The coffee machine beeped in apparent approval, printing out a spectrographic analysis in its foam that would later win an astrophysics award. The boss stared at Ryan for a long moment, his hair processing this perspective shift. "Wonder," he repeated slowly. "Humility, understanding our limitations." His face lit up. "That's it! We'll market our ignorance. Dark comets because not knowing is half the fun. Or something legal, we'll let us say." And so, dear listeners, the marketing campaign turned from hype to humble curiosity. The tagline, eventually approved, was simply, "Look up and wonder." And that brings us to the fascinating science behind why some of the universe's most interesting objects are the ones we almost didn't see at all. Now that we've seen how impossible it is to market the unknowable, let's talk about why some of the universe's most fascinating objects are the ones playing cosmic hide-and-seek. Unlike the square-haired boss's understanding of social media trends, the science behind dark comets actually makes sense, even when it's confounding our expectations. The story begins in October 2017, when astronomers at Hawaii's Pan-STARRS 1 telescope spotted something odd. The object was moving too fast to be bound by our sun's gravity, which was interesting enough. But the real mystery began when they tried to figure out what exactly they were looking at. Initially classified as an asteroid, our interstellar visitor, dubbed Oumuamua, Hawaiian for scout or messenger, started behaving like a comet. Except it didn't really look like a comet. No visible tail, no coma, just an elongated or possibly pancake-shaped object tumbling through our solar system like a cosmic tumbleweed. It was as if someone had ordered a comet from Wish.com and received, well, something almost but not quite entirely unlike a comet. But wait, there's more. As astronomers tracked Oumuamua's journey through our cosmic neighborhood, they noticed it was accelerating slightly, as if something was giving it a gentle push. This is normal behavior for comets, caused by ice sublimating and creating a tiny rocket effect. The problem? They couldn't see any of the usual signs of this process, and that's when astronomers had to face the elephant in the room. That is, if the elephant was invisible, moving at 26 kilometers per second and refusing to behave according to our expectations of how elephants should work. When we return after this brief orbital period, we'll dive deeper into why dark comets challenge everything we thought we knew about these cosmic wanderers, and what Oumuamua might tell us about our place in the universe. Plus, we'll explore why playing hard to get might actually be a fundamental property of interstellar objects. Welcome back, my celestial sleuths! While you were away, our automated response system finished calculating the odds of an interstellar object checking its Instagram mentions. Spoiler alert! Lower than the temperature needed to make a superconductor work in a Phoenix, Arizona summer. Now, let's dive deeper into what makes Oumuamua one of the most perplexing objects ever to ghost our solar system. Picture, if you will, trying to study something that's already leaving the party by the time you realize it arrived. That's essentially what astronomers faced in 2017. Except this party guest was breaking every rule of celestial object behavior we thought we understood. First, let's talk shape. Most asteroids and comets we've observed tend to be roughly potato-shaped. Apparently, potato is the universe's default setting for small space rocks. But Oumuamua? Initial observation suggested it was either a highly elongated cigar shape, up to 10 times longer than it was wide, or possibly a flat pancake. Now imagine trying to explain to extraterrestrials why we compared their potential probe to breakfast food.
Seriously?
But wait, there's more. The object was tumbling end over end as it soared through our solar system, causing massive variations in its brightness. Every 7.3 hours, Oumuamua would change in brightness by a factor of 10. It's like having a cosmic disco ball, but one that refuses to play by our understanding of physics. Here's where it gets really interesting. As Oumuamua approached the Sun, it accelerated slightly. Not unusual for a comet, as sunlight causes frozen gases to sublimate, creating a tiny thrust. The problem? We couldn't see any of this outgassing. No visible tail, no coma, nothing. It's like watching someone being pushed in a crowded elevator, but not being able to see who's doing the pushing. The acceleration was subtle, but undeniable. Careful analysis showed it was inversely proportional to distance from the Sun squared, exactly what you'd expect from radiation pressure. Unfortunately, for this explanation to work, Oumuamua would need to be less dense than aerogel, essentially a cosmic marshmallow tumbling through space. This unusual combination of characteristics led to some creative explanations. Harvard astronomer Avi Loeb famously suggested it might be an alien light sail, which honestly made about as much sense as any other explanation we had at the time. Though I should note that alien technology is usually astronomy's equivalent of shrugging and saying a wizard did it. More conservative theories suggest it might be composed of extremely light materials. Perhaps hydrogen ice that sublimated without visible outgassing, or a fluffy aggregate of dust particles held together by gravity. It's like trying to explain why your clumsiest friend somehow never spills their coffee. Technically possible, but suspiciously unlikely. Dark comets, it turns out, might not be as rare as we think. We just can't see them. Imagine trying to count black cats in a dark room while wearing sunglasses. Now make those cats interstellar, traveling at 26 kilometers per second, and you'll start to appreciate astronomers' challenges. But wait, there's more. The discovery of Oumuamua, followed by the interstellar comet Borisov in 2019, suggests that our solar system might be getting far more extrasolar visitors than we previously thought. We're like a cosmic Grand Central Station, except we only notice the passengers wearing reflective vests. Current models suggest there could be at least one Oumuamua-sized object within Earth's orbit at any given time. We just can't see them because they're either too dark, too small, or too busy composing existential LinkedIn posts about their interstellar journey. The implications are staggering. If dark comets are common, they could be constantly delivering material between star systems like cosmic mail carriers, though with significantly worse tracking updates than FedEx. They might have played a crucial role in spreading the building blocks of life throughout the galaxy, which would explain why the universe's return policy is so complicated. This brings us to the future of dark comet detection. The Vera C. Rubin Observatory, currently under construction in Chile, will scan the entire visible sky every few nights. It's like having a security camera for the solar system, except instead of catching porch pirates, it's looking for interstellar interlopers. Meanwhile, theoretical physicists continue debating the nature of these objects. Some suggest they're fragments of distant exoplanets, cosmic shrapnel from violent collisions in other solar systems. Others propose they might be pristine remnants from the early days of planetary formation. It's like finding a time capsule, except this one is actively running away from us at escape velocity. The study of dark comets and objects like Oumuamua forces us to confront an uncomfortable truth. The universe is far stranger than we imagined, and our investigations might reveal more about our own limitations than about the objects we're studying. We're like detectives trying to solve a mystery where the evidence keeps questioning our understanding of what evidence should be. As we continue to scan the skies for more interstellar visitors, each discovery promises to bring new puzzles, new theories, and new reminders that the cosmos has a sense of humor about our attempts to categorize it. Though I suspect somewhere out there, Oumuamua is still tumbling through space, completely indifferent to our ongoing debates about its nature. Well, my interstellar investigators, we've reached the end of another cosmic conundrum. Today we've learned that in the vast marketing campaign of existence, some things resist being branded, no matter how many black turtlenecks you Photoshop onto them. We've discovered that dark comets, like the most effective marketing campaigns, are more about what we don't see than what we do. Our first interstellar visitor, Oumuamua, proved that sometimes the most fascinating objects are the ones that refuse to fit neatly into our categories. Though I suspect the square-haired boss is still trying to get it to do a TikTok challenge. Our quantum-entangled coffee machine has started a new research project comparing the acceleration patterns of dark comets to morning coffee consumption trends. Early results suggest that both demonstrate unexpected behavior when observed too closely, though only one leaves mysterious stains on the break room counter. Want to stay updated on our cosmic corporate chaos? Visit us at multiverseemployeehandbook.com, where you'll find fascinating science news, sneak peeks of upcoming episodes, and our interdimensional blog, now featuring the coffee machine's weekly astrophysics column, Grounds for Scientific Inquiry. And if you enjoyed today's episode, why not share it with a friend, family member, or passing interstellar object? We're particularly popular among beings of unknown origin and composition, traveling at 26 kilometers per second. Though I should note that if your friend exists in a quantum superposition of states, you may need to share the episode multiple times to ensure they receive it in at least one reality. Remember, if you need support with this episode, our help desk exists in all possible universes between 9 a.m. and 5 p.m. local time. Though given the dark comet currently passing through their server room, response times may vary by several astronomical units.
this is Alex from Montreal, Quebec, Canada. The Multiverse Employee Handbook was created by Rob Corrigan, is edited by Joseph Cooper, and narrated by David from 11 Labs. All science fact-checking is done by Wolf Edmonds. The Employee Handbook staff includes Hugh Mann, Dr. Eric Hale, and Miss Hanley. Please be sure to subscribe to get updates on new episodes.